Hey guys, so we're starting our second section of our new unit. The new unit, hopefully you remember, is called Periodic Functions and Trigonometry. In the first section, we learned what a periodic function is, what a cycle is, amplitude, maximum, minimum, things like that. We saw examples of a periodic function. We practiced finding midlines, but now we're going to work on angles, their measure, vocabulary. We're going to review some things from geometry, and then we're going to graph trigonometric functions, which, you guessed it, are periodic. That's why periodic functions and trigonometry share a unit. So let's get started. Angles and their measure. Here are a few important things that you definitely want to write down. First thing, we have a picture in the top right corner of essentially what is necessary for us to have an angle. Typically, an angle is formed by two rays meeting at a common vertex. You learned about rays in geometry. A ray has a closed point on one end and an arrow on the other end, which allows it to go on indefinitely in one direction. A segment has a closed point on both ends, and a line has an arrow on both ends. The first ray is called the initial side. We didn't really talk about initial sides in geometry because the level of trigonometry that we did back then was very different. This is going to layer algebra and geometry into a more advanced unit of trigonometry right now, so our vocabulary is going to have to develop a little bit. So again, that first ray is called the initial side. The initial side actually never moves. It's always going to be completely horizontal and pointing to the right. The second ray is called the terminal side. The terminal side begins overlapping that initial side. However, when we form an angle, the terminal side is going to sweep open. Now, if that angle, which we will probably represent with a Greek letter, theta, alpha, beta, whenever we don't know what its measure is, that angle, if it sweeps open in a counterclockwise direction, which obviously means not clockwise, that angle will have a positive angle measure. However, if that angle sweeps out in a clockwise direction, that angle will have a negative angle measure. It seems a little bit backwards. People usually want clockwise to be positive, but remember, if an angle starts on the positive x-axis and sweeps up and into quadrant 1, we call that a positive angle. You drew angles all throughout geometry. Typically, we would draw them inside of a polygon. Now, from algebra into precalculus, we're going to draw our angles on the xy plane, where the vertex will rest at the origin, and the initial side, which is horizontal, pointing to the right, will always overlap the positive x-axis. Now, before we can practice really drawing angles in this so-called standard position we're about to speak about, we should take a few seconds to review the quadrants, because if you don't know what number each quadrant is, you really won't be able to describe where an angle terminates. An angle terminates in the quadrant or on the axis where the terminal side lands. So if your terminal side lands in quadrant 2, you need to be able to say so. If your terminal side lands on the negative y-axis, you need to be able to say so. Quadrant 1 will begin at the initial side when it sweeps up in the positive direction in an attempt to go counterclockwise. If you continue with that sweeping motion, the next quadrant you'll hit is quadrant 2 in the top left corner. Then quadrant 3 will be the bottom left corner, and last, quadrant 4 can be found in the bottom right corner. Now, to draw an angle in standard position, we're always going to begin with what we described a few minutes ago. You'll draw your initial side stemming from the origin and pointing out along the positive x-axis. Now I chose to do this in purple because I'm actually going to be drawing the angle theta, which represents approximately 50 degrees, and I have it indicated here in purple. I say approximately 50 degrees because I'm obviously not using a protractor to do this. I'm just using what I know about a few different angle measures to place the terminal side. Since I know that the positive y-axis would bring me to 90 degrees of right angle, and I also know that 45 degrees is half of 90, I know to draw my 50-degree angle a little bit further than halfway through quadrant 1. Drawing the initial side and terminal side is actually not enough. This doesn't qualify as standard position. In order to have your angles drawn in standard position, you have to include this little arrow. You probably noticed that I drew in between those two sides. This angle will only have an arrow on one end. It'll start on the initial side and then it'll sweep, showing which way you drew your angle. So this way I know that I have an angle that didn't even make one full revolution around, and it went in the counterclockwise or positive direction. The details of this drawing also provide me with enough information to be able to confidently say that the angle measure indicated in this picture is between 0 and 90 degrees. Now we're going to draw the angle that I have written in red. Alpha is supposed to equal approximately negative 310 degrees. First thing we do is start with the initial side, exactly how we did the purple one. Now, we just said a few minutes ago that negative angles will have a clockwise rotation. We're still just approximating and not using a protractor, so we're going to use right angles to help us make our way from the initial side to the terminal side. If we go clockwise through quadrant 4 to the negative y-axis, that would be a negative 90-degree rotation. Now, if we continue a little bit further and we pause with our revolution at the negative x-axis, that would be negative 180 degrees. As we continue another 90 degrees, we will have traveled negative 270 degrees once we reach the positive y-axis. Now this is actually the perfect opportunity to pause and remind yourself of what angle we are actually trying to draw. We are trying to draw the angle alpha equals approximately negative 310 degrees in standard position. We've already gone negative 270 degrees. It's a good idea to figure out how many more degrees past where I am right now do I need to travel in order to reach negative 310 degrees. Since 310 minus 270 is 40, that means I need to travel 40 more degrees in order to reach the terminal side. Each quadrant represents a 90-degree angle. Since 40 plus 50 is 90 degrees, my purple angle of 50 degrees and my red angle of negative 310 degrees will actually terminate in the same place. When two or more angles terminate in the same place, we call those coterminal angles. So the angle measure between the y-axis and the terminal side of these angles was 40 degrees, and between the x-axis and the terminal side of these angles was 50 degrees, which added to make 90 degrees. Now we're going to draw in angle beta in standard position. Angle beta is approximately positive 410 degrees. Angle beta needs to sweep out in what direction? Clockwise or counterclockwise? Beta is going to be drawn in a counterclockwise rotation because it's a positive angle. How many degrees can be found in one full revolution? 360 degrees. Since 410 degrees is more than 360 degrees, so this angle will sweep out more than one full revolution from its initial side, counterclockwise through quadrants 1, 2, 3, and 4. 360 degrees is how far away from our goal of 410 degrees. 410 minus 360 is 50 degrees. That means we have to go 50 degrees further. However, 50 degrees also happen to be my purple angle theta. 410 degrees will also be coterminal with 50 degrees and negative 310 degrees. How many angles will be coterminal to these three angles? There are an infinite number of coterminal angles. You can always add one more revolution in the positive direction, and you could always subtract one other revolution in the negative or clockwise direction. Angles theta, alpha, and beta not only all terminate in quadrant 1, but they actually all terminate in identical locations. So this is really why it's super important that you have these little arrows that loop around and show you how you got to the terminal side of the angle. In order to differentiate them from one another, you need to show how they got to where they are, so that little looping arrow is key. The last thing we're going to talk about on this page is something called quadrantal angles. Quadrantal angles are the angles that are not in a quadrant. Quadrantal angles are the angles that separate one quadrant from another. That means our quadrantal angles are going to be multiples of 90 degrees. 90, 180, 270, 360, even 900 degrees would qualify as a quadrantal angle. So all of the angles that land on the x or y axes, or you can say the angles that are between any two quadrants, angles that are multiples of 90 or negative 90, those are all of our quadrantal angles. Those angles come in really handy because key things happen there when we start dealing with trigonometric functions, so you're going to want to be very comfortable and familiar with those angles. Here we have a few examples where I want all of you to practice drawing an angle. I know it kind of seems ridiculous that it's even something that I'm asking you to do, but you'd be surprised how important all of the little details are and how easy they are to mess up. Pause the video, take a few minutes, copy this down. You can either go ahead and try to draw them on your own first, maybe in pencil or erasable pen, and then unpause, or if you really need help drawing it, draw your axes and copy the questions, and once you're ready, unpause the video. We're going to draw 45 degrees right now. 45 degrees is a positive angle. That means it will be opening in the counterclockwise direction. 45 degrees is exactly halfway to 90 degrees, so that means this angle should be right in the middle of quadrant 1. I'll also include my little arrow looping around to show that I went from the initial side, counterclockwise, 1/8 of a revolution. Next, I need to draw negative 90 degrees. Negative 90 degrees will open up in the clockwise direction. Negative 90 degrees is a quadrantal angle. That means it is a multiple of 90 or negative 90. It will land between which two quadrants? Negative 90 degrees lands between quadrants 3 and 4. It is on which axis? When you answer which axis, you can't just say X or Y. You have to say positive or negative as well. Negative 90 degrees lands on the negative Y axis. In geometry, you learned about an angle called a straight angle. A straight angle is 180 degrees. We can look at the x-axis as a straight angle. With the initial side on the positive x-axis, we'll use up 180 degrees to get to the negative x-axis. How much further do we need to go if we're already at 180 and we need to get to 225 degrees? 225 minus 180 tells us that we need to go 45 more degrees. If we're going 45 more degrees in the counterclockwise direction from the negative x-axis, that will put us right in the middle of quadrant 3. Last, we have 405 degrees to draw. 405 degrees is definitely more than 360, so that's more than one full revolution. If I add another 90-degree angle to 360 degrees, that will put me at 450 degrees. An easy way to keep track is to basically count by multiples of 9. 9, 18, 27, 36, 45, 54, on, and just stick a 0 at the end. So 90, 180, 270, 360, carry on from there. So 405 is somewhere between 36, 45, or 360 and 450. That means it's more than one full revolution, but less than an extra quadrant beyond that. To find out how many degrees past 360 we need to go, we'll just use subtraction again. 405 minus 360 is 45 degrees. So we're going to be exactly in the middle of quadrant 1 yet again.